covalent bonding. So covalent bonding is an entirely different animal than ionic bonding is, right? In ionic bonding, one atom loses an electron and becomes a cation, and the other one gains an electron and becomes an anion, right? So we've got a positive and a negative. There's an extremely strong electrostatic force of attraction right there, right? So you can think of it as the cation donating the electron almost, right? It's very, 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 very strong bond between that cation and that anion. We call that an ionic bond. When we're talking about covalent bonding, okay, that's totally different. In this scenario, electrons are being shared, right? So in ionic bonding, we gain or lose electrons to become electronically stable, and that's what gives us our cations and our anions. Whereas in covalent bonding, we share electrons between atoms, and that's what gives them electronic stability. Okay? If you want to talk about naming, right, these two words get thrown around. Sometimes you hear molecule, sometimes you hear the word compound. What's the difference between them? Well, traditionally, we talk about a compound as a substance containing ionic bonding and a molecule as a substance containing covalent bonding. Okay, that's the only real difference there. Will I make fun of you if you accidentally use one in place of the other when you're writing a lab report? Probably not, right? But just so you know, I like to inform you for your general knowledge, right? What's the difference between a compound and a molecule? It generally refers to the type of bonding. All right, now again, electrons are shared. So here's an example using H2, okay? In this example, this pair of electrons is shared between these two atoms. And down the road a little bit, we'll talk about what degree that pair is shared. Is it shared evenly? Is it shared unevenly? Here it's being shared perfectly evenly. But we will get into examples later on where it's not. What does that do to things? Okay, so you can look at a formula and tell immediately the bonding type just by looking at the formula, okay? If it's ionic, it'll be one metal and one non-metal, right? Metals form cations, non-metals form anions, so metal plus non-metal. Or it could be a metal and a polyatomic ion, or it could even be two polyatomic ions, right? Ammonium nitrate, for instance, that's two polyatomic ions. So that should be a dead giveaway. You've got ionic bonding. Whereas in covalent bonding, it's always two non-metals, okay? And just FYI, when you're looking at the periodic table for this in particular, we're pretending that hydrogen is sitting next to helium in the non-metals group, okay? So if you see something involving hydrogen, for instance, we're pretending that hydrogen's sitting in the non-metals. So just keep that in mind, all right? But this is one of the things that will be on your proficiency, okay? It'll say name, type of bonding, and then formula. Okay, so if I give you the formula, you'd figure out what its name is, and then from the formula, you can tell if it's ionic or covalent. All right, prefixes are the same. We use the exact same prefixes that we do in the hydrates, which is why I teach these two things together. And then you use the prefix system to tell how many of each element you have. All right, so when we're looking at, let's pretend we're doing this example. Na3P. What's the name of that? You just took a quiz, right? Sodium phosphide, right? Okay, that comes from Na plus and P3 minus, right? Does that 3 factor into the name at all? No, it doesn't, okay? In covalent naming, those subscripts do factor in, okay? They do factor in. The subscripts are part of the name. That's another dead giveaway between ionic and covalent bonding, because you're not going to see tri and penta and tetra and octa in ionic nomenclature, but you will see it in covalent nomenclature, because that's a big, big difference. So let's go through these together. Boron and bromine, are those both non-metals? Confirm this on your periodic table. Yes, they're both non-metals. So what's the prefix for 4? Tetra, good. And what's the prefix for 8? Octa. So it would be tetraboron octabromide. They don't exactly roll off the tongue easily, right? So they are kind of a mouthful. Again, you have to memorize those prefixes. Okay, that's something you have to learn. There are only 10. You probably already know the majority of them, if not all of them. All right. Are both of these nonmetals? Yes, they are. So what's the prefix for 6? Hexa. And the prefix for 9? No, not right. So selenium and silicon. Silicon becomes silicide. So hexaselenium nonosilicide. Okay, the second element's always going to end in "ide." Does this make sense? Covalent nomenclature is totally different from ionic nomenclature. It's a completely different animal. So make sure you understand how to do this. And again, you can tell that this is covalent nomenclature first and foremost. If I gave you this and asked what kind of bonding it is, if you see prefixes, that should automatically make you think, yep, this is definitely covalent, right? Because ionic doesn't use those prefixes. Or you can look at the periodic table, right? Selenium and silicon, both nonmetals, that's a giveaway too. And if I asked you what type of bonding it was, you can look either from the formula, right? Se, Si, or from the prefixes, right? Both of those would tell you. You're dealing with covalent nomenclature here. Now, here's something that happens for ease of pronunciation, okay? It happens when something ends, when you're naming an oxide and the prefix ends in O or A. So let me give you an example of that. Dinitrogen pentoxide, right? We dropped the A because dinitrogen pentoxide, that doesn't flow off the tongue and it kind of ends up getting dropped anyway, right? So it's dropped from the spelling too. So it's dinitrogen pentoxide, right? That back-to-back vowel is tough to pronounce. It usually ends up getting merged into one anyway. Does this make sense? So if we were naming water, let's just practice. H2O, right? Water has covalent bonding. Water's not got ionic bonding. It's very, very much covalent bonding. So what prefix goes with 2? So that's dihydrogen. Is it monooxide? It'd just be monoxide, right? Okay, that second O gets dropped. Makes sense? That's the systematic name for water. Again, that A got dropped. Okay, here's another important detail. If there's only one of the first element, we drop the mono only if it's the first element. Okay, so for instance, NO2 is nitrogen dioxide. Think about CO2, that's carbon dioxide, right? It's not monocarbon dioxide, it's just carbon dioxide. Same thing here. It's not mononitrogen dioxide, it's just nitrogen dioxide. Now, if the second element only has one, you still keep the mon, right? Like in dihydrogen monoxide, right? You still keep the mono, drop the O if it's an oxide, right? But you still keep that prefix if the second element only has one, but not the first, right? So it's not called monocarbon monoxide, it's just called carbon monoxide, okay? Make sense? Go home tonight, make sure that you've got a carbon monoxide detector in your house. If you don't, go buy one. Save your life, literally. Saved my family's life a couple years ago. Okay, let's pretend that this is an exam question. Which is the correct answer? A, B, C, or D? C, good. Why is it C? What? You don't need the repeating the O, right? So that eliminates those two. And you don't need the mono for the first one, right? So all you're left with is C. Good. Okay, take a second and name these. Just take a quick second. Okay, what prefix goes with 5? Penta, and what prefix goes with 7? Hepta. Are these both non-metals? Yes, I mean, technically GE is a metalloid, but it's close enough. So pentagermanium, excuse me, germanium. Oh, I said it right. Geranium is a plant, germanium is the element. Pentagermanium heptoxide, right? We dropped the A. It's not heptaoxide, it's just heptoxide. All right, are phosphorus and bromine both nonmetals? Yep. So prefix for 4 and prefix for 3. So tetraphosphorus, tribromine. Did you get them right? All right. So again, you can tell type of bonding by looking at the formula. So what kind of bonding is in water? We already talked about it. What about ammonia? Ionic or covalent? Covalent, right. Remember, we're pretending hydrogen's over next to helium. CO2 would be covalent, NaCl, ionic, N2O, covalent, CaCO3, ionic, NaHCO3, ionic, MgSO4, 7H2O. That's actually ionic. That's just a hydrate, remember. And what about this one? MgOH2. Ionic. Good.